us insert element one by one and balance tree. Okay, let us see. Consider the following example. Note down. Consider consider the following example. Consider the following example. Note down elements 50, 20, 60, 10, 8, 15, 32, 46, 11, 48. These are the elements. These are the elements. You need to insert these elements and you need to balance the tree. Note down elements 50, 20, 60, 10, 8, 15, 32, 46, 11, 48. Now you need to insert these elements and you need to make it balance. You need to apply these rotations if it is not balanced. Okay. Solution. This is very important. Please note down, students. Now here you know that insertion will be same as a binary search tree insertion. What is binary search tree property? All lesser elements will occupy as left child. All greater elements will occupy as right child. Step 1. Remember that here insertion of AVL tree is similar to the binary search tree insertion. You need to follow binary search tree property. Here, what is the first element? 50. Students, step by step you need to note, but in one step only I'm going to say everything. But please note down step by step. What is first step? You need to insert first element. First element will be the root element 50. Step 1. See, in one step only I'm doing, but you need to do in stepwise. 50. You are inserting first element. What is the next element? 20. 20 is greater or lesser? Remember, all lesser elements will occupy as left child. All greater elements will occupy as right child. 20 is less than 50, right? That's why it will occupy as left child. Now, sorry, I forgot one thing. 1 second, student. Step 1. B equal to, I'm sorry, you after inserting, you need to find balancing factor. For balancing factor of see root node 50, there is only one node. Balancing factor is 0. Remember, after inserting you need to find balancing factor for each and every node. Step 2. Second 20 you need to insert. Which side you need to insert? 20 is less than 50. Less than means you need to insert as left child. Insert left child. Now find out balancing factor. What is the balancing factor of 20? 20 is a leaf node, right? For all leaf nodes, balancing factor will be 0. B equal to 0. Write down 1 second. B equal to 0. Now, next element 50 completed, 20 completed, 60. Where you need to insert 60? 60. Compare with root element. Always remember you need to compare with root element. 60 is greater than 50. Greater means it should come to right side as right child. 60 insert. You need to do step by step here. I am explaining in only one step, but you need to do step by step. Now, find out balancing factor. Here B is a leaf node, right? Remember, for leaf node means which does not contain any children. For leaf node, balancing factor is 0. Students, this is important. Insertion operation. Okay. Yes, this tree is balanced because you got B equal to 0. B equal to 0 or B equal to 1. B equal to -1 is -1 means tree is balanced. Okay, this tree is balanced. Now, what is the next one? 10. 50 completed, 20 completed, 60 completed, 10 you need to insert. Where you need to insert 10? Compare 10 with 50. 10 is less than 50. Less means you have to come to left side. Left side there is another element. Compare 10 with 20. 10 is less than 20. Less means it should occupy as left child of 20. Left child of 20. Now find out balancing factor. Now find out balancing factor. Just wait. See, for every node, see, remember, for after inserting, for each and every node, again for root node, again you need to compare. For each and every node, again you need to compare balancing factor. Okay, sorry, again you need to do balancing factor. Sorry, find out balancing factor. Now, you know, for leaf node, balancing factor is 0. 10 is a leaf node. Now again you need to find out balancing factor for 20, for 50, for 60. Remember, okay, remember, please remember that in previous step also you need to find. I didn't say, but you need to find in previous step also. After inserting, for each and every node, again for whole tree, for each and every node, again you need to find. Now let us find balancing factor for 50. What is the left subtree height? See, left subtree, left path, take left path. How many links are there? 1, 2. 2, and right path is 1. 2 minus 1, you got 1. 2 minus 1, 1. Now find out balancing factor for 20. 20 left subtree height is, see, 1. There is only one link, 1. Right subtree, there is no right child, 0. 1 minus 0, 1. For 60 it will be 0 only, because 60 is a leaf node. See here, whether tree is balanced or not. See the balancing factor. Balancing factor must be 0, 1 or minus 1. Yes, this tree is balanced 1. Okay. Now, next you need to insert element 8. Element 8. Where to insert element 8? 8 is less than 50. Come to right side. Compare with 20. 8 is less than 20. Come to again left child. Left subtree. There is element 10. Compare with element 10. 8 is less than 10. Okay, less. 8 is less than 10. So 8 must be inserted here. Please do it. Okay. Now what you need to do? You need to find balancing factor for every node. Not only node 8, for every node you need to find balancing factor. Again, please find out, students. Please draw the tree step by step. You need to do it. No, not in a single step. For each and every node, again you need to find all balancing factor for 50 node, for 20 node. Remember, after inserting, you need to find balancing factor for whole tree, for each and every node. Let us find. See here. For node 50, what is balancing factor? B equal to, what is the height of left subtree? 1, 2, 3. Total, there are 3 links. So 3. Write down 3 like this. Right subtree height, there is only one child, only one link. So 3. 3 minus 1, 2. Balancing factor is 2. Next, find out B equal to, for 20. For 20, what is the left subtree height? See, how many links are there? 20. You need to count from 20. How many links are there? Left subtree 2. 2 links. Right subtree, there are no right children. 0. 2 minus 0. Balancing factor is 2. For 60, 60 balancing factor is 0, because for leaf nodes, balancing factor is 0. For node 10, B equal to, left subtree height, there is only one child, one link, 1. Right subtree, there is no right children, so 0. 1 minus 0, 1. Now balancing factor for 8, for leaf node, balancing factor is 0. Now see here, this tree is not at all balanced, because at node 20 you got balancing factor is 2. At node 50 you got balancing factor is 2. It is violating AVL tree property. Now you need to know at which node you need to balance. Okay, see here, at node 20, you got B equal to 2. At node 50, you got B equal to 2. So at which node you need to balance? There are 2 nodes. You need to know, right? At which node you need to balance? Let us see. Now see, always take path from inserted node. Which node you have inserted? 8 node. After inserting 8 only, tree is not balanced, right? So, take path traverse from last inserted node. What is the last inserted node? 8. Because of this node you have inserted, tree is not at all balanced. So, traverse from inserted node. See, inserted node to root node. Okay, traverse. See, once again, from lastly inserted node. What is lastly inserted node? 8. From 8 node, you need to traverse in that path only. From 8 node to 8 node to root node, please traverse. So while traversing, at this path, while you are traversing from while you are traversing from node 8 to the root node, see, while you are traversing, you got at 20 node b equal to 2. Now you need to apply rotations at this node. Remember this. See, you here you will have doubt. Here two nodes are there. Node 20 and node 50 b equal to 2, b equal to 2. That means it is not balanced. Here there will be question. A question will arise. What is that means? At which node you need to balance? That you need to find out. If you want to find out at which node you need to balance, you need to traverse from lastly inserted node. Which node you have inserted? 8. From that node to you need to traverse towards root. While you are traversing towards root, from downward to upward, while you are traversing, if you have encountered b equal to something else other than 0, 1 or -1, see, here at node 20 you got b equal to 2. That means now at this node you need to balance tree. Okay, so first you need to know which rotation you need to apply. If you want to balance means you need to apply rotations. Now, anyone can answer, students? Which rotation you need to apply? Anyone, please try to answer. Here you need to apply rotation. Which rotation you need to apply? How will you know? Which rotation you have to apply? Either LL, RR, LR or RL. Which rotation? Students, you need to answer. Please answer to my question. Teja? Teja, which rotation you need to apply? RR. No, it's wrong. Teja, it's wrong. Once again, see here at node 20, here it is not balanced. Now, from node 20, you need to apply some rotation. Remaining students, Haripriya, Meghana, Rajalakshmi, Neelaveni, Mahesh Babu, remaining members, Haripriya, Harshita. Yes, very good, Haripriya. LL rotation. Yes, see here. Once again, see. See, take the deeper path. From node 20, take deeper path. What is deeper path? Left path. Already in previous I have said, right? See, at node 20, it is not balanced. Now you need to know which rotation you need to apply. Either LL, RR or which notation you need to. How will you know? Take a deeper path. Okay, deeper path from root node 20. From 20, there is only left path. Deeper path is left. That means LL rotation. Always remember, from that node, from imbalanced node, from that node, see some deeper path. Okay, see some deeper path. Left path is deeper. So you need to apply LL rotation. LL rotation. Note down, students. LL rotation means rotate right. Rotate right. That means like this you need to rotate. So take only subtree. Students, please take only subtree and rotate. What is the subtree? 20, 10, 10, 8. Take this subtree separately because you need to rotate it right side. LL rotation means rotate right side. That means you need to rotate which node? At which node you got imbalanced? At node 20, right? That node you need to rotate right. Okay. Resultant tree will be 10, 20. 20 is rotated right. 8. Okay. This is the resultant subtree. Now attach this subtree to 50. See here. 50, 60, right? Attach it. Resultant tree is 50, 60. Attach this subtree. Insert this subtree. 10, 8, 20. Okay, now this is a balanced tree. Again, you need to find B, okay? Again, you need to find B for each and every node. After balancing for each and every node, find out B and see whether it is balanced tree or not. B 1 2 2 1 1 0 0 0 1 1 0. Okay. See here. Once again, students, please see. Once again, see. This is the tree you got. Here, left path is deeper. So LL rotation. You need to rotate at which node? 20 node. You need to rotate right side. LL rotation means rotate right. Take this subtree separately. See like this. 20 10 8, take separately and rotate right. After rotating you will get like this 10 8 20. Now you need to insert this 10 8 20 to the previous tree. 50 10 8 20 60 like this. 50 10 60 8 20 like this. Okay, now again find out B. After finding out B, it must be balanced. Okay, now this tree is balanced. Please try to understand. Shall I continue, students? Or should I repeat? Students, please respond. This is very, very important. AVL tree. You will get something confusing. You have to practice at least twice. Already in notes, there is everything. Please download notes from Moodle. Download latest one. If you have downloaded previously, I have uploaded. If you have downloaded it, delete it. Freshly again, I have uploaded new one. Download it and practice AVL tree insertion deletion. Shall I continue, students? Up to here, did you understand? See, if you see my notes means you will understand very well. After listening, please try to refer my notes. Students, please respond. Shall I continue? Haripriya, Teja, Ishwar, Mahesh Babu, roll number 8. Okay, now what's the next element? See, 8 completed, right? 15, you need to insert 15. Let us insert 15. To this result entry, you need to insert, okay? Take this result entry. This is a result entry. For this result entry, insert 15. Where you need to insert 15? 15 is less than 50. Come to left side. 15 is greater than 10. That means come to right side. Right side, there is another element 20. Compare 15 with 20. 15 is less than 20. That means you need to, less means as left child. 15 must be inserted as left child. Okay. After inserting, what you need to do? You need to find out B. Balancing factor for each and every node. For each and every node, you need to find out. Do it. For leaf nodes, balancing factor is 0. Now, for node 50, find out what is the longest path. Left subtree 1, 2, 3. There are total 3 links. Coming to right side, there is only one link. 3 minus 1, 2. 3 minus 1, 2. Next, coming to 10, left subtree height is only one link. There are 2 links here. 1 minus 2, minus 1. B equal to minus 1. Next at 20. At 20, come to 20. B equal to left subtree height is only 1. There is only one link. Right subtree, there are no children. 0. 1 minus 0, 1. See, B equal to left subtree height minus right subtree. Okay. Now see here. 1 second, rotate right. Now see here. At which node you got imbalanced? See, once again, see this tree. At which node you got imbalanced? B equal to 2 at node 50. Okay. See, at 1 second, 15 you have inserted, right? Now you need to traverse from 15 to root node. Please traverse it. While traversing, see, any node is imbalanced. See, traverse from 15 node 20. B equal to 1 only. Okay. Traverse again. Traverse to the node 10. For node 10, B equal to 1 only. Okay. And traverse up to root node. But coming to root node, see, B equal to 20. You got, remember. After inserting the node, you need to find out at which node you got imbalanced. So traverse from 15. Okay, 15 you have inserted. While traversing from 15 to root node, if you have encountered any balancing factor equal to 2 or 3 something else, from that node you need to balance. See, once again, traverse from 15. You need to traverse from 15 to root node. While traversing in this path, see whether any node is imbalanced. Here 20 is balanced only, node 10 is balanced only. At which node you got imbalanced? At 50. Now at 50 you need to, what you need to do? You need to rotate. Which rotation you need to apply? Anyone please answer? Teja, which rotation you need to apply? Anyone? Teja. Not only Teja, anyone can respond. Teja, respond. Which rotation you need to apply? Once again, see. At node 50, it is imbalanced. From node 50, you need to check which path is deeper. Teja, are you there? LR. Okay. Haripriya, just respond. I will say whether it is correct or not. Harshita, Meghana, roll number 8. No one is responding. LR. Okay. Just I will say which is correct. Please respond. Harshita, Neelaveni, Kavya, Soumya, Mahesh Babu. Only 2 members is responded. Okay. See here. 1 second. Yes, very good. LR rotation. Very good. See, at which node you got B equal to 2 something, B equal to something other than 0, -1, 1 you got. At which node? Node 50. Now, from node 50, see which path is deeper. Because of which path this tree is not balanced. See, left. See here, which path? Left and right. Okay, because of left, right, that means you need to apply LR rotation. From that node, you need to see which path is deeper. See, left and right path is deeper. That means LR, you need to apply it. Okay, students, LR. See, first you need to take bottom tree. Okay, from 50 below tree you need to take. What is below tree? This one. 10, 8, 20, 15. Take that one. 10, 8, 20, 15. Okay, below part. See, once again, see students, one second. LR means first you need to apply RR rotation. Second, you need to apply LL rotation. Always remember, you need to take below tree. Okay, at which node you got imbalanced 50? Below tree, take below tree. What is below tree? This one. 10, 8, 20, 15. Once again, note down. 10, 8, 20, 15. First, what you need to apply? See, LR rotation. RR you need to apply. RR means you need to rotate left. Resultant tree. That means 10 you need to rotate. 10 should come to the left child of 20. 20 left child is 10. You are rotating 10. 10 right child is as it is 8. And here, see here, 20 left child. 20 left child is 15. But here you have rotated 10 right. See here, you have rotated 10 as left child of 20. But there is a left child of 20. What is that? 15. 15 comes as right child of 10. Okay, this is a balanced tree, subtree. Please note down. This is a balanced subtree. Okay, for this tree, you need to take below tree, 50 below. This tree, subtree. Take this subtree and apply. First, you need to apply RR rotation. RR rotation means rotate left side. You will get this resultant tree. Now insert this tree to the previous resultant tree. What is that? 50. Okay, do it. 50, 60. Now what you need to take? See, RR completed. RR completed. LL you need to apply. Take upper part from root node. This part. Take this part and apply LL rotation. LL rotation means you need to rotate right like this. 50 comes as right child to 20. Again draw it. 20. 50 comes as, you have to rotate 50. 60. 10. 8. 15. 15. Okay, this is the balanced tree. Again find out B. At each and every node you need to find out B. Students, please try to follow. After my class, please refer my notes. Download it from Moodle. Yesterday I have uploaded new one. Delete old one if you have downloaded it. Please download it from Moodle and try to practice it. 1, 2. 2 minus 2, 0. Next, 1, 1, 1 minus 1, 0. 0, 1, 0 minus 1, minus 1. B equal to 0. Okay, tree is balanced. See here. Again you need to find, okay, remember after balancing, again you need to find the B for each and every node. So that you have to see, you have to check whether tree is balanced or not. Okay, now 15 is completed. Next one, which one you have to insert? 32. See, next element is 32. Insert element 32 for the resultant tree. Please try to understand, students. 32 you need to insert. Insert 32. After inserting 32, again you need to find balancing factor for each and every element. Please don't get confused. This is very easy if you practice it. Please try to refer my notes. See my notes after this class. Now insert 32, right? Where to insert 32? 32 is greater than 20. You need to come to right side. 32 is less than 50. Less means 32 must be inserted as a right child. After inserting, again find balancing factor for each and every node. For each and every node, after inserting, please try to find out. Please try to find out 2, 2, 2 minus 2, 0. 1, 1, 1 minus 1, 0. For leaf nodes, balancing factor is 0 only. 1, 1, 0. Okay, see here, for each and every node, you got either 0, 1. Okay, 0, 1. So this tree is balanced. This tree is balanced. B equal to 0, so you got B. Tree is balanced. Now, next, insert next element. What is the next element? 32. After 32, 46. You need to insert 46 to the resultant tree. You need to insert 46. See where to insert 46. Compare from root node. After inserting 46, again you need to find out balancing factor. Where to insert 46? 46 is greater than 20. That means you need to come to right side. 46 is less than 50. That means you need to come to left side. Left side, left child, there is 32. Compare with 32. 46 is greater than 32. So greater means as right child. 46 only. 46 only. One second. 46 only. 46. Now, after inserting, once again find out balancing factor. For each and every node, you need to find out balancing factor. Find the balancing factor. 2, 3. 2 minus 3 minus 1. 1, 1, 0. For balancing factor for leaf nodes will be 0, okay? 0, 1, minus 1. 1, 2, 2, 1. 2 minus 1. 1. Okay. See here, tree is balanced. For each and every node, please find out balancing factor. You got b equal to 0, minus 1, 1 you got. So it is a balanced tree. Now, insert element 11. Insert element 11. Next element. Next element is 11, right? Next element is 11. Please try to insert 11. Yes. Please insert 11. Again, you need to find out balancing factor after inserting. Where 11 is inserted? Compare with root node. 11 is less than 20 means you need to come to the left side, left child. There is element 10. 11 is greater than 10. Greater means you need to come to right child, right side, right subtree. Right subtree there is 15. Again compare 15. Compare 11 with 15. 11 is less than 15. That means as left child. Now b equal to, once again find out balancing factor. B equal to 0. B equal to, for 15, 1, 0, 1. For 10, B equal to 1, 2, minus 1. For root node 20, 1, 2, 3, 1, 2, 3, 0. Yes, see here. Tree is balanced only. Once again, try to find out balancing factor. Remember, after inserting, you need to find balancing factor. If balancing factor is 0, 1 or minus 1, tree is balanced. Other than 0, minus 1, 1, tree is not at all balanced. You need to apply rotations. Okay, tree is balanced only. Now, next element is 11 completed. 48. 48. Just wait. 48 must be inserted. Compare with 20. 48 is greater. Greater means you need to come to right subtree. Compare with 50. 48 is less than 50. Less means you need to come to left child. Yes, left subtree. There is 32. Compare that 48 with 32. 48 is greater than 32. Greater means you need to come to right side. Right side, right subtree. There is element 46. Compare 48 with 46. Sorry. Compare 48 with 46. 48 is greater than, now 48 must be inserted as right child. Okay, again find out balancing factor, students. Here at 32 balancing factor will be 2. Now please apply rotation, RR rotation. RR rotation you need to apply it. Do it. RR rotation you need to apply. That means rotate left. At 32 you will get balancing factor B equal to 2. So at node 32 you need to apply RR rotation. How will you find at which node you need to apply rotation? So from node 48, you have inserted 48, right? From node 48, you need to traverse up to root node. You need to traverse in this path. In this path, if you have encountered b equal to something other than 1, 0, -1, at that node you need to apply rotation. Now, which rotation you need to apply? See here. Right path is deeper, so you need to apply RR rotation. RR rotation means you need to rotate left. Okay, you need to rotate left. Now the balanced tree will be, again I will draw, see here. See, like this you need to rotate. 1 second. 46, rotate 32 to the left side. 32, 48. This is a balanced for subtree. Subtree balance. Now draw total tree. Total tree. See here I am drawing. $20, 10. Students, please download my notes and practice it. At that time you can understand. Now it will be little bit confusing to you. But please practice at least twice these rotations. If you have any doubts, you can call me. I will explain once again. This is the resultant tree. Now again you need to find out balancing factor. Okay, this is a balanced tree. Completed. Insertion is completed. Remember, after inserting each and every element, you need to find balancing factor once again. And AVL tree will follow binary search tree property. Remember that. All lesser elements will occupy as left child. All greater elements will occupy as right child. Okay, students. Please practice it. At that time only you can understand AVL tree. You can balance the tree. Download my notes and please practice the AVL tree insertion. Okay, unit 4 is completed. You need to practice well. Unit 4 is completed, students. Any doubts? Teja?